My name's Jason. I'm a product manager on Google Cloud. My colleague Michael is going to come up on stage a little bit later and show you a demo. So this is what's new in serverless compute. It's where we take you through all the things we've been working on since last Cloud Next, and some of the things that are coming up soon. We have quite a lot of content to get through. We'll do our best to get through it all. If there's any questions at the end and we have time, there's some microphones here in the middle. If we run out of time, we'll be loitering outside the room afterwards if you want to grab us for a quick question. And don't forget to rate the session at the end in the app. That'd be great. Okay, so let's get into it. Serverless on Google Cloud is, the way we think about it, is more than just compute. We have a view that serverless covers a full range of services. The rationale here is that if you want to build your application and you have an objective to not touch a server and not manage infrastructure, you need to do that across more than just compute. However, for today, we're going to focus just on that compute portion. And so there are many other sessions that will cover the other things. Today it's just compute, mostly. We do have a few things that perhaps deviate from that, but mostly we're scoped to compute. As far as compute goes on Cloud Platform, there's two products that create our compute suite today, App Engine and Cloud Functions. Many of you will probably already know these products. App Engine is our platform for building web applications, and Cloud Functions is our event-driven functions as a service offering. For those perhaps unfamiliar with App Engine, quick recap, source-based developer experience. So you write your application in your language of choice and you deploy source code to the environment. It's great for running your traditional web app with your web framework of choice, Express.js, Python Flask, Java Spring, etc. And it also comes with a range of features that are necessary for modern web applications, like versioning, traffic splitting, out-of-the-box TLS encryption, custom domains, etc. Many of the runtimes that we support this week are now generally available, GA. So PHP 7.2, Go 1.11, and Node 10. Those runtimes are all GA. We have some new versions of runtimes coming up. Java 11 is currently in alpha, and the long-awaited Ruby 2.5 now available on App Engine. There are some other sessions going on this week. If you want to know more about Ruby's particularly, there's a session tomorrow, and a general App Engine session also tomorrow, if you're interested. Okay, Cloud Functions is, as I mentioned, our event-driven functions as a service offering. Again, for those unfamiliar, you deploy a function, it reacts to an event, and you can call other APIs, and it's really the sort of the glue code solution in Cloud Platform. Along the same vein, we have new runtimes, GA, Python 3.7, Node 8, Go 1.11, and newly announced this week on Cloud Functions is Node 10 in beta and Go 1.12 in alpha. And finally, Java is coming to Cloud Functions. Java 8 in alpha this week. And there's another session you can go and look at to learn more about Java on Cloud Platform, a serverless Java developer's journey tomorrow. So that'll tell you more about how we do Java in GCP on serverless. Okay, some new features that we talked about, or we alluded to last year on Cloud Functions, and we'll go into a little bit more detail now. So max instances, last year we referred to this as scaling controls. What this allows you to do is set a maximum number of instances of your Cloud Function. So it sets an upper bound of number of instances. You configure this at deployment time. And it's really useful for situations where you have perhaps a back-end system that has a limited capacity. So I'll just take you through how that works. The little cloud is the internet. So a request comes into our front end, and we'll route that request to an instance of your Cloud function. So far, so good. As more requests come in, more instances of your Cloud function will be created, assuming that the current ones are busy, to serve those requests. What max instances allows you to do is specify an upper bound to that. So you'll tell us, in this case, max instances are 4. We won't create more than 4 instances. Subsequent requests that come in will be queued. Now, this is important because you may have a spike in traffic that hits the boundary of your max instances, but it may only be temporary, and you don't want to necessarily immediately reject that request. So the queuing gives sort of a smoothing effect to this spikiness in the traffic. Eventually, of course, if the system is too overloaded, meaning that the requests on the front end are too many for this max instances to deal with, then at some point that will be rejected. But no matter what, if you have your downstream system that has a maximum capacity, for example, a database with a maximum number of connections, then the max instances will ensure that you're not overloading your underlying data set. Overloading the underlying database will cause problems with all serving functions potentially. So that's max instances. That's available now. Another feature that is also long awaited is serverless VPC access. So this allows you to connect both Cloud Functions and App Engine to your VPC. Let's talk about what that looks like. So a VPC today, it's available in Cloud Platform, allows you to create a network boundary around more than 2 potentially, but in this case 2 regions. So you have a shared network address space. With the serverless VPC access, via a connector, you're able to send traffic from your Cloud function into the VPC. So if you have resources in your VPC already, maybe you have services on a virtual machine, or you're hosting a Redis cluster, whatever it is, you can now access that through Cloud Functions and App Engine. Additionally, if you have on-premises networks connected to the cloud via VPN that are then connected into the VPC, you can route traffic all the way from your Cloud function through the VPC back to your on-premises infrastructure. So as I mentioned, great for accessing services running on GCE or GKE. If you're running a third-party solution hosted on a VM. Some Google services are run in this network, for example, Cloud Memory Store, and any services running in your own data center. Okay, rolling through the features. I told you we had a lot to get through. Per function identity. What this allows you to do, I'll skip this slide and go to the more interesting one with the nice picture of the cat. So let's say you had a function that was reading from a cloud storage bucket. And you have a developer that is wanting to deploy this function that reads from a cloud storage bucket. The function has an identity. It has a service account in the Google Cloud vernacular. That identity has some role associated with it. And so in order for that function to read from the storage bucket, the role needs to have the appropriate permissions. It needs to be able to have the authority to read from that storage bucket. Now, your developer may have a different role. He might be a developer. But as a result of needing access to the function that needs access to the storage bucket, by extension, this developer implicitly needs the same role. Otherwise, there's a possibility of a privilege escalation. So this is fine. This is great. This works. Well, let's say you have another function that wants to read from a different bucket. Well, previously, both those functions would have the same identity. And if they had the same identity, that identity has the same permissions, which means that this other storage bucket needs the same permissions as the first one. Well, there's a sort of an implied level of access here that you may not want. You may not have intended for your developer to access this other bucket, but you didn't really have a way to opt out of that because both functions shared the same identity. Well, what we really want to do is swap that identity with a different identity that has a different role and a different set of permissions, give the bucket the appropriate level of access, and this means that this developer can no longer access this bucket. So it really gives a narrowing effect and a more fine-grained control over access control on a per-function basis. Cloud Functions today can be deployed in these 4 regions, 2 in the US, 1 in Europe, 1 in Asia. This week, we are making available 2 additional regions, 1 in London and 1 in Hong Kong. Okay, I'm going to switch gears a little bit. I mentioned we're talking about serverless compute mostly. This is part of the mostly category. Cloud tasks, for anyone who's used App Engine in the past, there is a feature of App Engine called task queues, which is a very, very popular feature, asynchronous queuing product. Unfortunately, only available if you're using App Engine. Well, Cloud Tasks is the first-class GCP product that does a very similar thing. It's GA this week. So let me just take you through the canonical use case for Cloud Tasks in the context of serverless, something like Cloud Functions. So imagine you had written a function that does 3 things, whatever those things may be. The second part of that, let's say, was a heavyweight operation. Maybe it was transforming an image or doing some sort of heavyweight task that you realize that doesn't need to be synchronous. It doesn't need to be in the request flow. It can happen at a later time. Now, perhaps traditionally you might have spawned a thread to process this asynchronous job and returned quickly to the client, to the requester. Well, threads have this side effect that they're perhaps not durable. If your process fails completely, what happens to that asynchronous work? The alternative is that you can use Cloud Tasks. So you enqueue a task, it will happen in the background asynchronously, and then you return quickly to the caller. Some of the features, additional features, which I'm going to talk about in a second, it has a configurable retry policy. Again, with the sort of the traditional way of perhaps spawning a thread, if that process that you spawn the thread to execute failed for some reason, there's not necessarily a durability and a retry policy that you can apply to that. So Cloud Tasks allows you to do that. There's rate limiting, dynamic scheduling. This is really cool. You can say, execute this thing, but do it in 1 hour from now. You can target the output. So in this case, I'm not really concerned about, in this case on screen, I'm not really concerned about what happens after. But you can target arbitrary HTTP endpoints, and you can add authentication. I'll talk about that in a little bit. That's also new this week. So a little bit more about rate limiting and retry in Cloud Tasks. So similar to the situation I described before with max instances, where you have a back-end system that has some sort of capacity limit. You can use max instances to control the flow of traffic into that back end, but sometimes it's hard to determine how many instances you need. If your back end system is, let's say, an API that has literally a rate limit, you can only call this API n times every m minutes. How many instances do I need to make sure I don't exceed that rate? Well, it depends, right? It depends on how quickly you're able to call the API. Well, with a retry policy, with rate limiting in Cloud Tasks, let's say you had this situation where you exceeded the limit of the back end. So what you could do is put a queue in front of it using Cloud Tasks with a rate limit. So let's walk through this. You have a bunch of requests coming in to Cloud Functions. Those Cloud Functions are enqueuing tasks onto a queue. The queue itself has a rate limit. So no matter what, the back-end system is not going to be overloaded. And so you just have that rate limit match whatever the capacity of your back-end is. If, for whatever reason, some request fails on that back-end, you can configure a retry policy so that there's an element of durability and reliability to it. And there's another session on Thursday that talks more about asynchronous tasks using Cloud Tasks. Cloud Scheduler. Is everyone keeping up? I'm not going to say very much about this. It's great because it's simple. It's a managed cron service, so you can schedule repeating executions. You can also have a retry policy if your execution failed. You can have arbitrary HTTP. So you could use Cloud Scheduler and Cloud Tasks to trigger something off Cloud Platform, just anything that's available over on an HTTP endpoint. And it also includes this authentication, which I'm going to talk about in a moment. And there's another session there again on Thursday that involves uses Cloud Scheduler extensively. Okay, so I mentioned in a couple of scenarios this idea of Cloud Scheduler and Cloud Tasks emitting or calling services via HTTP. This has perhaps a problem where the service that's receiving this call from Cloud Tasks or Cloud Scheduler needs to validate and authenticate the person calling them. If you stand up a web server to be called on a schedule, how do you know that it's Google Cloud Scheduler calling you? How do you verify that identity? And more importantly, if it was just, well, I can verify that it's Google Cloud, that's great, but how do I know it's my Google Cloud? How do I know it's my project and not some other Google Cloud project calling me? So let's say you're executing a Cloud function or you're executing some arbitrary HTTP endpoint that's out there on the internet. Well, you can associate, in the same way you associate an identity to a Cloud function that we described earlier, you can associate an identity to the resource that is sending you these pings, that's sending you these requests. So your Cloud Scheduler job or your Cloud Tasks queue will have an identity. At the time the HTTP request is sent, we will put an OpenID connect JWT token in the HTTP header that corresponds to that identity. It's a token that expires, but when you receive that token, you can validate that using standard open protocols to validate the authenticity of the claims made in that token. I mentioned Cloud Tasks and Cloud Scheduler. This capability is also available as of today in PubSub. So Cloud PubSub also allows you to push, it has a push subscription, allows you to push messages to HTTP. Now you can attach an identity to your subscription in Cloud PubSub. When it pushes the HTTP request, the message, it will carry with it a bearer token, an OpenID Connect JWT token. Okay, so that's all the things that we've been working on in the last 12 months in terms of Cloud Functions, App Engine, Cloud Tasks, Cloud Scheduler. But this is Cloud Next, so what are we doing next? Many of you may have already seen some of this, but here we go. So traditionally, serverless has a couple of these characteristics. It's typically source-driven. You write your code, function or app, whatever it might be. Obviously, it's serverless, so I don't want any operational overhead, so it's no ops. And it has a characteristic that you typically pay only when you're using it. It scales to 0, but some things can be constraining. So adding custom libraries or native binaries can sometimes be cumbersome. Arbitrary runtimes. You know, we talked about the runtime support expanding on App Engine and Cloud Functions. But what if I want to run Erlang or Rust? Well, you're sort of requiring the platform providers to do that and to do a lot of work before you can get that. Well, there's another solution that people have been using for this, and it's containers. And so the container is sort of the lingua franca of portability of code. So it's obviously container-driven. Unfortunately, most container platforms do have at least some amount of ops. You're creating a cluster, you're managing a cluster of containers. And the billing model is typically you pay for the instances of the machines that are running your containers. But it has these advantages where you can specify arbitrary libraries, you can specify arbitrary runtimes. It operates in a very similar way to a virtual machine. So what we're announcing this week is a new product in GCP called Cloud Run, which brings those two worlds together. So you get all the benefits of a container, being able to run an arbitrary runtime, arbitrary custom libraries. You specify whatever you want in that container. But we give you all of the operational model of a serverless product. So you have no ops, you only pay when it's being used. So we're going to talk a little bit about this. There's three aspects that we identify with Cloud Run. One is container to production in seconds. You know, this was a hard requirement for us. It's one thing to say, well, you can run a container, but if you have to jump through 20 hoops to get there, then it's not really serverless. There's no rule book that says serverless has to be easy, but we all know that that's how we want it to be. So I should be able to give Google a Docker image and curl a URL in a few seconds. It's natively serverless. What does that mean? Well, if you go onto the Cloud Console and you create a Cloud Run serverless, it will be serverless by default. It will be no ops, you pay only for what you use, scales up fast, it scales to 0, etc. And the last point is it's one developer experience wherever you want to go. I'll talk more about this a little bit later. But we also have a version of Cloud Run that runs on your GKE cluster. So if you're already a GKE customer or you already have made an investment in Kubernetes and that's where you want to run the bulk of your workload, you may have developers internally that want some of the agility and benefits of the serverless developer experience where I just have to deploy and I get something back in seconds. Well, you can run that same capability on your GKE cluster. And some of you may have encountered this term Knative. I'll talk a little bit more about that as well. So Cloud Run is Google Cloud's implementation of the Knative serving specification. I'll pause that and leave it there. I'll come back to it later. It's very simple. It looks like this. If you literally take a photo of that OCR and type it into a console, it will work. But rather than do that, let me show you. OK. This is Cloud Console. I'm logged into the Cloud Run section. So here on the left nav, we have a new option called Cloud Run. Over here, I just have a Cloud Shell. I'm not going to do anything fancy. I just wanted to show you how easy it is to create and deploy a new service as a container using Cloud Run. So I have a very simple Node.js application. In fact, I'm so lazy, I literally copied it from the Hello World example on Express.js. The only thing I changed is this port variable. But other than that, it's identical. I have a package.json. For those familiar with Node, will know what that means. For those not, it's the canonical deployment descriptor for Node.js. And the only thing I changed here is this start command here. And so if I just run, I have to specify my port. If I just run that regular old npm, nothing fancy going on, and I preview that in the browser. There we go, Hello Cloud next. Let's just quickly change that to prove that it's real. OK. I don't know if I have to restart, but let's do it anyway. Refresh. OK, so that's real. So I have an index.js, a package.json. The only other file I have here is a Docker file. And this is pretty lightweight. It's just inheriting from the default official Node.js 10 image. It runs an npm install, and then it calls npm start, the same command I just called in the console. Well, I have a Docker file, but Cloud Run takes Docker images. So how do I turn my Docker file into a Docker image? I could run Docker build locally, and that would produce an image and upload it to a repository, and that would work. But we have a service, actually, that will do this for me. Here's my cheat sheet. So I'm going to use a product that we have in Cloud called Cloud Build that, surprise, surprise, builds Docker images. So live demo. Let's see if it works. Of course it's going to work. I have Cloud Build over here. Let's refresh that. There it is. You can see I did a few earlier. It takes about 20 or 30 seconds. Oops. Okay, it's still building. And it's done. There it is. Okay, so that has given me this image down here. So this is a Docker image in the repository that has my Node.js app. So all I need to do now is go into Cloud Run. I'm going to create a service. First thing it's going to ask is for my container image URL that I just created. It's picked up the name by default. Location is fine. I'm going to check this box. What this is saying is, let me hit the URL without any authentication. Now, by default, it's off. You need to authenticate yourself against your own service, just with your Google Cloud account. For the purpose of this demo, I'm going to make it public so that I can hit it without having to do any of that. And I just go create. So what this is going to do is, so I already built my Docker image. It's uploaded to the repository. This is going to pull down that image, set up all the routing and configuration necessary, and make my service available. And you see it gave me a URL. It generated a TLS certificate for me. If I click that URL, there's my service. There's something else I'll just give you a little sneak peek at that I'll come back to later. Okay, avert your eyes. It's YAML. I wanted to just point out that the first line, this is the YAML file description of the service that I just created. It's a Knative compatible service. Now, for those that aren't familiar with what Knative means, that's not going to mean a lot to you right now. I do have some slides later on where that will start to make more sense. Okay, back to slides. Can we switch back to the slides? Pretty please? Okay. That was Hello World. So what do you get? Well, when you deploy a Cloud Run service, you get HTTPS. You can also add, I didn't demonstrate this, but you can also add a custom domain. So within a few minutes, you can start your container-based web application, add your custom domain, and you're off to the races. The allow authentication on or off tick box that I mentioned before, well, we talked about the identity-based authentication for Cloud Tasks, Cloud Scheduler, and PubSub. Well, we will automatically validate that token for you. So if you leave that tick box unticked, and then you enqueue a task into task queues, let's say, that's pushing via HTTP to your Cloud Run service, we'll handle all that authentication for you. So the Cloud Run service is not invocable from the outside world, but it is invocable by you either directly, if you authenticate yourself, or asynchronously via one of these services. So HTTPS plus the OpenID Connect JWT. Yes, and it's automatically validated, as I mentioned. Okay, I want to sidebar just quickly to talk about concurrency. When we use the term instance, that's what we use to describe an instantiation of your function app or container in this case. It's typically where you nominate resources like memory and CPU. Importantly, it has a life cycle that might be beyond your request. So we'll create an instance, you send a request to it, we serve the request. That doesn't mean we instantly kill the instance because, of course, another request might be coming and we want to save that cold start time. So an instance has its own life cycle. And then concurrency, the way we refer to it, is the number of requests processed at the same time on a single instance. So it looks like this. Request comes in, same diagram as before, hits the front end, and is served by instances. Now, in the case of a product like Cloud Functions, concurrency is one, and you can't change it. One function will deal with one request at one time. And that's great because it means the programming model is very simple, the billing model is very simple. While your request is running, you're paying the end. But there's a problem. Well, your function may not be using all the resources on that instance all the time. And CPU is the biggest culprit here. You're unlikely to be CPU bound for the entire duration of your function. You're going to be I/O bound, you're going to be doing other things network bound in some way. So zooming in on this, in this scenario, it might be better if we could utilize more of the machine during the request. If we could move some of that CPU utilization into the gaps of another instance. And we would do this by changing concurrency. Well, why is this new? We've been doing this forever on virtual machines. Well, it's not new, but it's new for serverless. And particularly it's new for serverless because the serverless billing model has traditionally been you pay for the lifetime of a request. Well, what is the lifetime of a request if there are more than one? How do we make concurrency serverless? Well, here's a way of describing it. Here's my instance. The instance has a life cycle, as I mentioned, that may be beyond the life cycle of your request. A request starts and ends over a period of time, and in a traditional model, that's what you would pay for. You would pay while that request is being served. Well, what happens when another request comes in offset to that? First one starts, second one starts, first one ends, second one ends. Well, it's pretty simple. We just extend it to the boundary. So the billable time now becomes the time where at least one concurrent request is being served. So why do we want to do concurrency? Why do we want to complicate our lives? Well, there's a couple of really important benefits. One is you have fewer cold starts. Imagine a ramp up in QPS. If every instance of your function or application can only deal with one request at the same time, every subsequent request that comes in at approximately the same time needs to spawn a new instance. Spawning a new instance creates a cold start. Well, if you can serve some of those requests on an existing instance, you have necessarily fewer cold starts. You therefore have a faster ramp up if you have a spike in traffic. And importantly, you have better utilization. So the underlying machinery is going to be better utilized, which has both speed, efficiency, and cost implications. The one caveat is that you give away some of the simplicity in the programming model. If you're storing state in global scope, outside of your function, for example, or outside of your app, well, you have to be aware that there may be more than one request concurrently accessing that global state. So maybe don't do that. And you do open yourself up to more race conditions if things are competing. So I want to invite my colleague Michael onto the stage. He's going to do a much better demo than mine that will show some of these benefits.
Thanks, Jason. Jason, do you switch?
Yeah.
Okay, perfect. So I'm excited to be talking about some of the work we've been doing in Cloud Run to achieve fast scaling. So why is fast scaling important? Well, for serverless workloads, we tend to have bursty request stream. And so for these bursts, we want to be able to quickly react and handle all the requests with low latency. And of course, we don't want to be paying for instances when we're not using them, and so we want to scale down. And as Jason mentioned, if we have too many instances, then we have a lot of cold starts, and then we have the higher latency associated with that. So the trade-off or the balance we're trying to strike here is to create lots of instances on demand as needed, but not to create too many so that both the cold start latencies and the bill is appropriate for that workload. And so what I'm going to be demoing here is kind of the fast scaling that we have for Cloud Run that's an order of magnitude faster than what we've had in our existing serverless products like App Engine and GCF. And so here's a monitor of how many instances we have right now. I'm going to deploy an existing image that I've already built. And then the workload is going to be pretty simple. I'm going to use Apache Bench to send 10,000 concurrent requests. Each one of these requests is just burning CPU and executing for 1 second. So given that I set max concurrency equal 1 in this deployment, and I have 10,000 requests, I expect concurrent clients rather, I expect around 10,000 clients on the order, and I'll explain why later it's a bit higher. So let me start the workload now. There's some lag in this monitoring, and then you see the number of instances start up, and it's a matter of seconds. We're going to see around 10,000 instances start up. And so this is pretty cool. And you're going to see that the number of instances slightly overshoots above 10,000. And the reason we do that is we need to be able to handle any spike of workloads that's higher than like if we're going to get more requests, we want to be able to handle that. And we also want to not have the instances have too high of a utilization. Oops, okay, so the test is now done. Oops. Yep, so request test is done. And so that's okay. I loaded quickly. I started 10,000 instances. You can see here in a matter of seconds. Kind of less than 10 seconds I started, or 8,000 instances here. And so for my next demo, what I want to show is what Jason referred to earlier in terms of concurrency. Most requests aren't spending all the time burning CPU. They may be doing requests to kind of say cloud machine learning or Google Cloud Storage. And so we can have concurrent requests at the same time. And so when I deploy, I can get to say how many concurrent requests I want. And in this case, I'm going to say I want 5 requests. And now I'm deploying a new version, and instances are not shared between revisions, even of the same service. And so I'm going to have cold start for the new workload that I run now. Okay, and so here we go. There's 0 instances right now. Okay. It's pretty old school. I'm going to run Apache Bench on 5 different machines, starting 10,000 concurrent requests on each one of them. And then, as with the previous test, you expect to see kind of a rapid scale up to an order of 10,000 instances. But unlike the previous test, we're now having multiple requests per instance. And so we're getting an order of 50,000 requests per second. This test runs for around 1.5 minutes. So these are pretty impressive numbers. But why do we need this kind of rapid scaling? I want to give you a few examples of customers' use cases that we've had on App Engine and GCF, Google Cloud Functions. And so on App Engine, New York Times hosts a crossword puzzle. So every day when the crossword puzzle is released, there's a significant ramp up in terms of clients trying to get the crossword. And because in App Engine we didn't scale this fast, the New York Times tends to ramp up manually instances to handle that load. Well, with this rapid scaling, customers don't have to think about that. They don't have to predict how much load is coming in. The system will very quickly scale up to the necessary number of instances. Another example is Snap runs most of the compute workload on App Engine, and they do very rapid deployments. They want to do deployments of new code every few minutes. And when you have millions of queries per second to a large service like Snap, you want to be able to handle, kind of migrate from the old version to the new version really quickly. And so this kind of rapid scaling allows us to spin up a lot of the new containers for the new version and migrate traffic quickly to the new version. Now you'll see here that as the client requests went down, we're down to 280 instances, but you're not paying for that. So we quickly spun them down, but you're only paying for the instances that are running your workload, and so these instances are available because we lazily garbage collect them in case we want to get more requests. And so I just want to add that we have a shared infrastructure for App Engine, Google Cloud Function, and Cloud Run, and we're going to be enabling this in Google Cloud Functions as well. App Engine's billing model makes it difficult to support this because there's a minimum of 15-minute billing for the instance, so we're only going to enable this in Cloud Run and Google Cloud Functions. And then finally, just a couple of caveats. By default, we are limiting every Cloud Run service to 1,000 instances, but if you need more, let us know and we'll increase that limit, something like 10,000 if you need, and we're just limited by our data center capacity. And the other caveat is this fast scaling is brand new, we're still finally tuning it, and so it's not enabled for all projects yet, but we're going to be enabling it shortly for every project. So I gave a few examples of kind of customer use cases for this kind of rapid scaling, and we want to put this out there and see how you use it, and we're excited to see how you use this capability. Thank you.
Okay. I just want to reflect a moment on what we just saw. Michael sent some load to a service that went from 0 to 10,000 instances in a matter of seconds. It really is incredible. And my colleagues back at the office told me to say it's over 9,000. I didn't really know what that meant. Okay, so just in summary, serverless compute on Google Cloud, Cloud Functions, App Engine, and now the new service, Cloud Run. There's a great session if you want to know more about Cloud Run, which is today, actually, this afternoon. Container once, serverless everywhere, anywhere, rather. Okay, circling back to the start, I mentioned this thing called Knative. For those unfamiliar, Knative is an open source, community developed platform that allows you to build, deploy, and manage modern serverless workloads. It all starts with Kubernetes and Istio. We've defined these three categories of components. There's Knative build, Knative serving, Knative eventing. Cloud Run that you've seen is the middle component. It's the serving part of the Knative specification. And above all of that, there's a declarative API service. We use that term declarative. It's a Kubernetes-style API service. I showed you the YAML file before of the Cloud Run service. That is the declaration of that service that you would send to Knative to instantiate or to provision the resources necessary for that resource in your Knative cluster or service, if it's in the case of Cloud Run. It's been community developed. We've been working closely with folks like Pivotal, IBM, SAP, Red Hat, etc., to design a serverless developer experience and a serverless platform that meets the needs of customers. As I mentioned, it's based on Kubernetes and Istio. Cloud Run is our instantiation of Knative. Cloud Run is the fully serverless, fully managed, pay for what you use. You can also run Cloud Run on GKE, and they are both compatible with Knative. So I haven't gone very deep on the Knative side. I'd encourage you to look more into it. There's a session that covers how to use Knative in hybrid use cases. That is on Thursday. If you want to know more about Knative, I'd encourage you to go along to that. So that's the end. We made it. Don't forget to rate. And I think we probably don't have time for a lot of questions. Michael and I will make ourselves available outside the room immediately after this session. And if you want to know more, these are the canonical locations for Cloud Run and for serverless on GCP.